Sine diagram up here.
Are we doing everything but now for this?
Yeah, we're on to this new question. Sine diagram, great fun.
Nice.
3 over 2 minus 3, we know it crosses at that. Let's put it just here. I'm not going to mark it though. Minus 3 is here. That's an intercept. 3 over 2 is here. I have a vertical asymptote as well, so that's...
I thought those are the asymptotes.
No, they're the intercepts. We got values. Yep.
That's the only asymptote.
No, there's the oblique one. Wait, how do we find? How do we know there's an asymptote at minus 2 here? Oh, yeah, I see. Let x. Let the
1 over 2. You have to have one more point out. 1 over 2. That's where the other one crosses the x-axis. The oblique.
Oblique.
Okay. So you...
Can I please go to the bathroom?
Yes. You'll watch the video? Oh yeah. You don't get this much?
That's so bad.
I get the egg.
Just say, go only to Nico.
Okay. You get the x, you don't get this one?
Yeah.
Oh, this?
I don't.
Well, we're going to do it again, so we'll just have a little think. This is we don't put the oblique one on this. Why do we think not?
But it's like a...
The oblique, of course, will cross the x-axis, but it's not an entire barrier to the shape of the function.
But like, it doesn't go through that line. Right?
No, it doesn't go through that line, but we're just looking at the first sine diagram. You only put vertical asymptotes. Okay, so you can remember. I've definitely never seen this type being asked for a sine diagram in an exam.
It would only be the one I've hit.
Yeah, I might have seen that once, but I think it was only on a sample paper.
Oh, so it might just be nothing.
Yes, might just be nothing. Okay. What do we need to do? Plus and minuses between these two things. Let's think about what they're going to be. Before minus 3.
Can we draw it again first? I feel like that makes sense.
You want to draw it first? Okay, we can draw the x and well.
So what's like the general form for finding asymptotes? For vertical, we let the denominator equal 0.
Yes.
And for horizontal, what do we do?
Horizontal, this type is just 0. It's always just 0.
Yeah.
And this type will have an oblique, so you do long division.
I know, but for other types?
The coefficients, well, we had it over here.
I don't know why, but I've written down that x equals 0. Is that correct?
No.
No.
No. That's to find an intercept. The y-intercept, you let x equal to 0. So you let the coefficients of x, one over the other, is the asymptote. Okay. We could sketch the function first. We know a few things about the function. We know it doesn't cross minus 2. It does cross at 3. And it also crosses at 3 over 2. But we also know there's an oblique asymptote, 2x minus 1. So yes, you can plot that. So it crosses at minus 1, and for every 1 box over, it goes up 2. Now, maybe I should move this a little bit, because that's 1.5. 1.5 is where it crosses. So for every 1 box over, it goes up 2. So it has to go through here, isn't it? Does that make sense? So that's at the, okay. So if something like this is the oblique.
Wait, what's the other line? There's like 2 lines next to 1.5%.
That's just where 1 is. I was just using it as a scale. Okay. So where is their function going to sit between these? It's going to approach, as it goes to infinity, it's going to approach this line somehow, and this line somehow.
Like another going in the middle of this.
How can the function be diagonal if you said like it rapidly approaches?
The function is not diagonal. These are the asymptotes.
I mean, sorry, the asymptote be diagonal.
Yeah.
Do you know what I mean? Because you were like, it's very steep, so then...
It's going to approach this. So a function approaching a diagonal line. So if we have I'll just draw it differently. So it can approach the diagonal line. As x gets bigger, it might just do this. Just go towards it like that. Not cross, but go towards it and just run along it for the rest of its life.
So it's not like exponentially.
So if you think about when we rewrote this, I know there's a lot going on the board here. Let's tidy it up. When we rewrote this, what was it? 2x minus 1 minus 7, was it? X plus 2. If you think about this, as the function approaches this answer, the bigger x gets here, the smaller the remainder is going to be, yeah? It's going to get closer and closer to this. The smaller this is going to get as x gets bigger. It's going to get closer to just this value. As x gets huge. Think about x as a really large number. This remainder is going to get so small. This will take over completely. It's going to go right towards this line because the remainder to it is so small. So if x is 1,000,000, this is going to be whatever, 1.99999 million minus a tiny fraction. So it's going to be super close to this line. It's going to be pretty close to this line at that stage. So as it goes in a direction, it's going to get closer and closer, just looking like this line at the two ends. Isn't it? It's going to run alongside, either on this side or this side, this line. It's going to get closer because the remainder of the division is going to get so small. Okay, maybe that's another way of looking at how this is an asymptote. Because the remainder of the division is going to go away to nothing. It's going to be a tiny fraction. I didn't get half as much done as I hoped. Okay. All right, how are we going to sketch it now? You wanted to sketch first before we do the sign diagram. So what have we got to go off? We know a cross is here, so we got to figure out what direction it's crossing. Is it crossing going up or crossing going down?
Let's put in x equals.
It's probably going to be a curve. I have a feeling it's going to go like this.
Yeah.
That would make most sense.
Yeah, 'cause it has to go closer.
Wait, what difference does it make? What? Sorry.
Well, is it going to go like this? Or is it going to go like this?
No,
It doesn't
has to
cross
be
the
first
asymptote.
one. It can't cross the diagonal.
It gets really close to the asymptote.
Okay, so you're expecting. So to test a point over here, you want to test a point between this.
Oh, that's the intercept.
That's an intercept, yeah.
Oh.
Okay, test a point between here and here. Did I rub out the intercepts? I did.
-2.
That's -2, is it?
No, that's the.
This is -3 and that's -2. Okay, so between -3 and 2, what are we hoping? Well, maybe after -3, are we hoping for negative values?
Yeah.
So after -3, so put in
-4.
-4 or -10 or something. Is it going to be negative or positive?
Can you do it?
Yeah, it will be.
Well, let's make sure and put in.
It looks like -4 squared times 2, and then that minus that does not equal 0.
So
What did I say?
I
No,
don't
the
know.
top will be positive and the bottom will be negative.
so you're going to get negative value.
Yeah, that's the thing.
So it's always going to be negative, yeah?
Yeah.
Yes, because if you think about it, a -10 or -100, this bottom is definitely going to be negative. And if you square negative, it's going to be super positive, super large positive number. So no matter what these are, it's not going to matter. So you're dividing by the negative, a positive divided by a negative. So it's always negative down here. Oh, I put it here. So between the two then, we're expecting some positive value, perhaps. But for it to cross the x-axis, we kind of know it's going to be positive. So I'm confident of saying it's positive between these two because it crosses. And it does what we expected. And it tends towards the oblique asymptote from the positive side.
Wait, are there 3 lines in this one or 2? How can you tell?
Can you tell if there's something here and here?
Yeah, and then one more on the right.
Well, it'd be interesting to know what the y-intercept is. What's the y-intercept of this? Didn't we work it out? When x is 0, oh we didn't. Negative 4.5. So the y-intercept is down here.
Oh, so there is something above this. Right?
So this is pretty much telling me the function is doing this, isn't it? It crosses here, we knew that. Okay. So will there be any values in this space, is the question you're asking.
No. Wait, can we test it? But like,
Well, what's interesting is, there's, you know the asymptote x equal to 2? Look at the function that approaches that. Doesn't it kind of cover everything from here to here? Like they're only...
yeah.
The x is covered. You can't go in there again because that won't be a function anymore. It won't pass the vertical line test. So it stops here and continues here after x minus 2. So that's the function we've drawn. And it tends, this is not very well drawn, it tends towards this line on this side. Doesn't it?
Yeah.
It goes more up like that. And that's the sketch.
What is the point there where it crosses the x-axis?
1.5.
Okay.
It's drawn very badly.
I think it's plus, and the 4, 3 over 2 is minus.
Oh yeah, so we can fill this in now.